All right, so even though this one looks more complicated, it is very, very similar. It's the same process. So we are going to have a number and we're going to have a couple letters in here. So if you look at the numbers 35, 25, and 20, there's another little divisibility trick you can use, which is if it ends in a 0 or a 5, we know that 5 goes into it. So I'm already going to try taking out that GCF of 5, and then I have to take a minute to look at the letters as well. I have m to the 4th n squared with that 35, which means I have 4 m's and I have 2 n's. And the second one has an m and an n to the 5th. There's nothing in front of that m, and they are not in parentheses, so that's really just an m to the 1st. You can include that little 1 there if that helps you. And then I have 5 n's. And then I have m, again, nothing with the exponent, so I'm going to put a 1 there. And n squared, so I have an m with 2 n's. Woo! So what that means for us is the most amount of m's that I could take out is 1. This only has 1, this only has 1, so I can only take 1 out of here. So we're going to include that with our GCF. And I've got, let's back that up and just make that slightly clearer. I don't want that to look like an N. If your handwriting is what throws you off, you got to spend a little more time with it. I have 2 N's, 2 N's, and then I have a couple N's in that one, but I can take out 2. So 2 is the most that I could take out there. Okay, n squared. All right, and I think it's a good technique to write them out on the side so that you can highlight and color them and see what's left over, cross things out maybe, okay? And then we're going to remember to take out 5mn squared. That's part of my answer, and then I have to go through and divide. So 35 divided by 5 leaves me with 7. If I take my 4 m's and I remove just that 1, I now have 3 m's left over. And then n squared and n squared knocked out all of my n's, so there's no n's in that one. And then I can move on to my next one. 25 divided by 5 gives me 5. The m and the m there are going to knock out. I'm not going to have any left over. And then I had n to the 5th, and I've removed 2 of them. So now I have n to the 3rd. And in my last one, 20 divided by 5 is 4. And it's a plus sign because this is a plus sign. It's going to match that symbol there unless you take out a negative in the front. All right, my m goes away and my n's go away. I don't have any variables left over here. So that's the end. And then, of course, you just want to do another little check. 7, 5, and 4. They don't share any common factors, so you know that you are done, and that is your answer. I'm going to take a minute and go over number 5 as well. I just want to show you, instead of making a separate video for this one, I want you to take note of something here. And this is a special case situation, okay? So this is special case. This is how they can try and throw you off. They love doing stuff like that, right, on SATs. Make sure you know what you're talking about. I want you to note how there's X's and Y's here, there's Y here, and there's no variables here. That tells me right away I cannot divide through by a variable because it's not in every single term. Of that same fashion, the number 5, the only numbers that go into 5 are 5 and 1. So the only thing I could take out of that is a 5. Okay, with the 10, I can break that into 2 times 5. So I do have a 5 in common there. But then that 7 only breaks down into 7 and 1. So since there's no common factors for every single piece here, this is unfactorable. Okay, so you can write unfactorable. If it asks you for the factored version, you can say unfactorable. Rewriting that works as an answer. Okay, and the key here is that we have nothing that is shared with all terms. We are going to go over a technique next week on how to break terms up. And if a couple share something and a couple share something, you can break something down. But when you have 3 terms like here, when you have a trinomial, or if you're just trying to take out a GCF in general, every single piece has to have it for it to be a greatest common factor. Otherwise, it's not common. Okay? So unfactorable is a possible answer.